I'll try to cover the what, when, how, show some demos of Azure Container Instances. And let me go straight into the subject. What is Azure Container Instances? Basically, containers, some people say it's virtualization, but it's not actually virtualization. It's kind of a sandbox on the kernel level. But what Microsoft did is that they've built the Windows containers in two different ways. They built it in the sandbox mode, and then they built it in the virtualization land with the Hyper-V containers. But containers are actually very cool. It's a sandbox model for applications that you can deploy without having to install runtimes, without having to install supporting dependencies. It's all self-contained in your container. You deploy it on a container engine such as Docker, and basically it takes some parameters and runs your application inside that container, inside that sandbox. And Azure Containers basically took away the underlying infrastructure that you need to prepare to run containers, such as Docker, the container engine, underlying OS that runs, that supports that container engine, and all the management of networking and all the infrastructure stuff, such as storage and everything, and put it in a cloud offering. And to give you an idea where it currently sits, I think if you got the model of hosting applications from basically your own data center all the way to serverless, I think Azure Container Instance sits in the middle between Azure Container Services, or running your container infrastructure on your own, on top of IaaS, and PaaS services, somewhere in there. Because you still have to configure your own container environment variables, etc., and you have to build your own container as well, and how it packs and how it configures your own application inside. So I think it's somewhere near the PaaS model rather than the container model. And with the new offering that Microsoft just announced with the Azure Container Services, Azure Kubernetes Services, that's even becoming a lot more interesting for the PaaS world. One of the features that Azure Container Instances has got. So you're only managing your own container, no underlying infrastructure, no VMs. You don't have to manage a Windows server or a Linux server, deploy patches, secure it, make it a highly available load balancing. All that crap is just away, and all you need to focus on is just your container. Your application inside that container, your supporting runtime, your configuration, put it together, give that container to Azure, it runs it for you, and it's just up and running. You don't need to care about all that underlying plumbing. Hyper-V kernel isolation, as I said, there's two models for Windows containers. Microsoft implemented Azure Container Instances on top of the Hyper-V model, the kernel isolation model. That's more secure by default, and it's more isolated, as if you're running your application in a VM on its own. Persistent storage, you can attach an Azure file share to your container, and you will get that file shared with the next time you run your container if it's the same version. Multiple CPU RAM sizes, so you've got some options there, like you can deploy your container and run it with 1 CPU, 4 CPU cores, 1 gig of RAM, 4 gigs of RAM, it's your choices, and every tier has its own price. And it's built by second. So if you want to deploy a container, run it for a few minutes, complete your workload and dispose it, you're only getting billed for those few minutes that you run your container, that's all. There is also a feature called container groups. It's not as much as an orchestration, rather than just if you have a couple of containers that depend on each other, you can still run them together. Those containers will share the same life cycle. They're starting together, they're stopping together, disposed together. They share the same host, so they're running on the same machine, same network, same storage volumes attached to them, similar to the concept of a pod on Kubernetes and DCOS. You can see in the diagram, basically, your main container takes the public IP address on the port, and your other container is just running locally on port 5000 inside the host machine. It's not exposed publicly. In terms of costs, had a look, and because it's preview, just be warned that this pricing will change. But mainly if you run like a small size container, one CPU core, 1 gig of RAM or something, will cost you about 150 Australian bucks a month, something like that, if you run it without stopping it. So it's pretty cheap compared to virtual machines, actually. So that's probably all the information that I managed to collect about Azure Container Instances. Because it's a very early stage in that service, still preview, Microsoft's still adding some features. So it's not really, does not have a lot of flashy features. It just basically works at the moment. And it's only available in the US regions. I think a couple of regions in the US West and US East. It's not available in Australia yet. But let me tell you a little bit more about its limitations and then when to use it. Limitations. So Azure Container Instances does not possess an orchestration mechanism. So if you're developing a microservices application, for example, and you need to deploy multiple containers and you need to coordinate failover between those nodes, coordinate scalability, elasticity, adding more nodes and migrating containers between those nodes or VMs, that's not Azure Container Instances, does not work there. It doesn't even try to become an orchestrator. Networking, discovery, monitoring, affinity, failover, scaling, all the orchestration features are not supported, or I think it's not even planned for Azure Container Instances. But that's just me thinking. Private VNets, that's not supported, and it only works if you have a long-running task. Basically, if you have a few seconds task attached to your container, and it will shut down after that, Azure Container Instances will try to restart your container and it will end up in an endless loop. So it doesn't work. Your task needs to persistently run on Azure Container Instances for it to be supported. So where does it sit in terms of all the other container offerings in Azure Cloud? Basically, if you want to run individual containers or a group of containers as a workload in Azure, you can use container instances if you don't require orchestration. But if you need more than that, there are other services that support these features. Like, for example, if you need a container registry, there's a different service for that. If you need a container, there's also Azure Container Services, which is basically something like Kubernetes and orchestration, and you can run it on multiple VMs and put it in high availability mode. And there's also Service Fabric. App Service supports containers now as well, but that's mainly for web apps and API apps. So how to use it, and I'll try to give you a little bit of the supported ways or the supported interfaces that you can consume Azure Container Instances or provision it, and we'll also do some demos as well. I love the Azure cross-platform command line interface much more than PowerShell, because mainly when you're working in containers and you're using lots of the Linux cool stuff, you'll have to use the CLI exploit. You don't have a lot of other options. So basically, the command, if you're using the Azure CLI, is that AZ container create, and these are the parameters. And if you notice that you have to give it the name, resource group, what image, and supports private image registries. So if you have an Azure container registry, you can use that as well. Supports integrating to that registry. You can pass environment variables, and you can specify CPU, memory, the IP address, and the port, which is by default is port 80. Or you can also use their Azure Resource Manager templates. Same parameters. So your resource is a Microsoft container instance, container groups, API version is still in preview, and then where do you want to run it, and the same parameters again, CPUs, memories, and ports, and the image as properties. The cool thing is that you can also use it with Kubernetes, but this is still experimental. There's an Azure Container Instance connector for Kubernetes. Basically, it acts as a node for Kubernetes, and that URL is the experimental connector on GitHub. It's open source. And yes,
that's where ACI will
Yeah.
Once you can orchestrate the Kubernetes, then it becomes much more.
Yes, you're right. So Azure, the reason why Azure Container Instances, or the reason why I think it doesn't try to be an orchestrator, is that they want to integrate with the orchestrators to become an endless capacity node that you can run containers on. It's pretty cool. I think it has got a lot of potential. So basically, your orchestrator will have an endless number of virtual machines to provision containers and decommission containers on, and they're pretty stable. So I think that's the future for ACI, is that where you can hook it up to your orchestrator, whether it's Swarm, Kubernetes, Rancher, whatever it is, and you can provision as much containers as you want without having to worry about the underlying infrastructure for that.
But does that work with managed Kubernetes?
I think yes, but I haven't looked at it yet. Basically, it's that the connector is using an API interface in Kubernetes itself. So I'm not sure if that API interface is supported in managed Kubernetes or not. It was just such a short announcement.
AKS is supposed to be 100% Kubernetes API compatible.
Yeah.
That's what they're saying. So eventually, maybe this will be supported by.
Yeah. So, but that connector still have got some limitations. I think they will work around it. So you can't do config maps, secrets, service accounts, volumes, logs, and kubectl exit. So I think they will work around these limitations very quickly. And once it becomes stable, I think that will be a very, very cool value proposition for ACI. Let me show you some demos. Is that fun to write for everybody? Okay. So I'll try to get a command line that we can use. I'll go through the commands and then I'll try to execute them to show you. But basically, what I'm trying to do here is create a resource group, and then the command that I showed you, Azure Container create, and then I'm giving it a name, it's ID container. I'm using the Hello World image that's in the tutorial in the MSDN Box website, or Azure Box website. One CPU, one memory, you give it to the resource group, and a public IP address.
Is that you can think from Docker Hub?
Yes, by default. Maybe I need to log in, but let's give it a try. I don't have to. Cool. So my container has been provisioned. It's basically Azure Container list, and that's my container. That's the IP address that it's got. Let's try to see if it's running. So while that loads, let's see. Yeah, here it is. It's in my portal. You can see it's running, and yeah, works. So that's an individual container, just taking one port on a public IP. It's running. So that's the simple scenario where you have just one single container. Second scenario I want to show you is when you have multiple containers that you want to run. Two containers in a container group. And basically, I'm going to try to create them through an ARM file, as a resource manager file. So is container create, container group name, and then I'm passing a template file. And my template file here is going to have a couple of containers, container 1 and container 2. There is an app and there is a sidecar to that app. And those two containers are taken from one of the tutorials in the Azure documentation as well. And if you see the resources, there is a container 1, container 2, having another different image. Just for the sake of shaking things up, let's change here, give it 2 CPUs for container 1, 1 CPU for container 2. They're running on Linux. We have port 80.
What might be a scenario where you use this deployment rather than just using a standalone ACI instance? Where might you do multi-container deployments?
So I'll give you a bit of an example. If you have 2 containers that run one single application, one is supporting the other, basically, or 2 microservices that talk internally to each other, but one of them is just exposing the API, or one is running a background task while the other is serving the web interface for the application. There are multiple scenarios. Let's see if that demo will still work. Second demo. Ooh. Image.
Did you sacrifice to the demo because of some money?
Yeah.
This is why they don't have text-based happening in movies.
Yeah. Sometimes I have to actually install a specific version of the XPlat CLI to get it to work because there's some bugs introduced in the last release, some regression bugs. But yeah, basically when it works, it will create 2 containers. Yeah. I'll be uploading those. I'll try to fix that template. I'll upload it to a Git repo and send the link to some later to share. But the coolest demo that I want to show you is actually the Kubernetes demo. How to run an ACI node in Kubernetes and provision containers from Kubernetes to the Azure Container Instances, and it's basically an endless capacity that you can utilize for Kubernetes. This demo is going to take a bit of time, but basically there's some prep that you might want to run. I already have run this command to install Kubernetes utils locally on my machine. I'm not going to run it again, but I'll share that script with you. Basically, it starts here. So creating a different resource group, creating Azure Container Services, which is Kubernetes cluster, basically. And I'm generating the SSH keys as part of that provision as well. It will save those SSH keys locally to my machine so that I can use it directly. And then I'm creating a service principal that I'll have to take its information and put it with the ACI connector for Kubernetes so that it knows how to connect to the ACI and provision the containers. So we'll do that practice together. And
The interesting thing with this is that when you deploy ACI instances, you could do it in any region. So you could deploy the same workload in multiple regions, let's say a web workload, and put a traffic manager over the top of it, and then orchestrate all
you
that.
can have multiple connectors in Kubernetes, multiple connector instances in Kubernetes. Each connector has its own parameters, which region, and its own service principal. And you can, when you are telling Kubernetes to provision a container, you can tell it which node you want to provision it on specifically, and this is how you direct it to which region or which. But you'll be taking away a bit of autonomy that Kubernetes has in terms of how to do failover and load balancing for your container. But it's a balance that you have to kind of do for your own workload. Basically, this is going to take a bit of time. It's provisioning 5 virtual machines and Kubernetes on top of them and putting them in virtual networks. So that provisioning takes a bit of time. Yeah, so Kubernetes on top of Azure Container Services. But again, there is a lot of infrastructure that you might have to manage one way or another when you're using Azure Container Services. But with the recently announced Azure Kubernetes service, you don't really have to manage all the underlying infrastructure. All you kind of get is just the Kubernetes interface that you can command without worrying about the VMs, operating system, patching, security, storage. There's a lot of underlying infrastructure that you have to manage for containerized workloads at the moment. So let me until that completes. Any questions? No. Anyone have got a workload with containers deployed at the moment? Production? No. See it?
The interesting scenario to make with this is containers is a thin layer over the top of a cloud-based services, where the lack of inter-network connect between instances is relevant, because I can push data to AWS RDS, Azure SQL Database, Service Bus, SNS, all those sorts of connections where I don't need a direct physical connection or a logical network connection like a traditional data center, where ACI fits perfectly.
Yeah.
Sorry, what we're doing here is ACS, not AKS, right? What you're doing right?
Yeah, I'm provisioning an Azure Container Service cluster, which is Kubernetes, 5 VMs and VNets, and it's a lot of infrastructure. You'll see here, look how many things that is being provisioned at the moment and configured for me.
AKS, you wouldn't have visibility if you are relying on
I actually haven't played with AKS yet.
Yeah,
So
that was announced very recently.
I don't know how it appears in the portal. Quite often, the early preview services, you'll get a single nondescript icon in the portal that will say the resource name and then hide everything else for you. Or it could literally just be an orchestration tier over the top of ACS for the time being. It's cool to see them do it, but it does sometimes the experience changes as it gets closer to general availability. Be clear about that. It's like the experience you get today might not be the one you get tomorrow. I mean, it happens like that in production anyway, right? Generally available services change all the time. You can log into the portal and go and everything go. Oh, it's got a new icon.
So while this works, let me try to probably get another command line. See if we can.
This is the only problem with ACS is it does take a while to spin up.
Yes.
What's the average time?
Maybe I get lucky.
10 minutes.
Depends on the region and the time of day.
So basically, the next script here is gonna do the cool stuff of connecting ACI, Azure Container Instances, with ACS, Azure Container Services. Lots of buzzwords and big names, but basically I'm registering Azure Container Instances as a node in Kubernetes. That's what's happening. So I'm calling ACS Kubernetes to get the credentials and save it locally. And I need to edit my connector specs file that I'll give to Kubernetes to put my service principal information like the tenant ID and the client ID and password so that Kubernetes can talk to Azure through that SPN. So ACS demo, ACI connected channel, subscription ID. Yay! So the ACS cluster has been created. Now I'm just getting an SPN I can use. Use this. Use my app ID. Don't try to hack my account.
JSON with them.
Curly brackets are unnamed, so name brackets.
So basically, I'll save that file. That file is what will be sent to Kubernetes to use as a node definition. And basically, it says use ACI connector, its version, that I'm giving it a name ACI connector, and I'm giving it the SPM information that the ACI connector requires to talk to Azure to provision containers on that node. So I'll go back here and I'll run the next one.
kubectl or kubectl?
kubectl.
kubectl.
Yep. We'll try to recreate that connector again. Oh, it already exists. kubectl. So what I'm going to do is just kubectl get nodes to show how many nodes do I have. So that's already talking to my Kubernetes in Azure. And you'll see that it has a new node called ACI connector. And it's ready. And the next command that I want to run is to actually deploy a container in Kubernetes. And I've created the configuration for that container already. For that pod, Kubernetes pod. And it's an Nginx container, and it's targeting the ACI connector node. So it will run on Azure. Creative, awesome. So let's have a look at how many pods do we have in Kubernetes. And you'll see that we have the ACI connector sitting in one of the pods, and Nginx is sitting in another pod. And that pod is the ACI connector, and that's the IP address. Let's see if we can access it. Yes, it works. So that's running in Azure Container Instances managed by Kubernetes. And if I want to look at my portal, you'll see here. It's sitting in a container group. So basically, these are the three main scenarios: running a single container, running a group of containers, or supporting a Kubernetes deployment as one of the nodes with limitless capacity. Any questions? Okay, so that's about it.